Inventory system can be hard and most intimidating system for game developers, especially for beginners. Today, I'll explain how to implement it, balancing simplicity and extensibility. We continue the series about making ARPG in Godot. Let's pick some items. Inventory is a huge system in terms of impact on gameplay. Sometimes inventory is a gameplay, basically the core loop, like backpack battles or backpack hero. Inventory management can either add tons of fun to your game, calm down the pace, or make you feel miserable. I think it talks about how bad Valheim inventory is going on for several years. And because it's quite complex and a large piece, I'm going to spend several episodes on this topic. Today, I'm gonna cover overall design and how different parts shape the puzzle. I also cover some details about Godot architecture approach I choose. To make it simple for understanding, I put everything together in a simple diagram. Please feel free to pause your video and return to the diagram at any time. Let's start from items. In most productions, item pipeline starts from some sort of asset management tool. Can be a spreadsheet, Notion project, special software, or even a dedicated database. Anything that helps to work with large amount of data. But the most important aspect to understand here is that item is data. In Godot, to represent data, there is a resource type. So we inherit item from the resource and add some basic fields, including other resources like 3D and 2D representation. Why do we need those? Because usually item in the game represented in several ways. In 3D world, it can be a mesh or even part of larger scene. In UI, the item is usually represented by a sprite picture and some description fields with item information. Inventory itself is just a memory storage that keeps track of items, their count and slots, so just a transient data. For the current demo, I created a few basic resource items. And let me actually show the process how I create them and add more items to spawner. So I have a bunch of items in my project tree. I organize them in some folder structure. And I have three base resources at the moment, twig, a stone, and a blueberry. Twig and stone already imported and set up in resource spawner, as you can see. As you can see, I have a list of configuration for each of the resources. It's basically the base item itself, the number of items to generate, and some base name to make sure that I can find them in debug easily. And I have, for this demo scene, I have 200 twigs and 200 stone generated. So I want to add blueberries to this list as well. So what I do first is I create a new resource based on base item type and call it the same way, blueberry. Once we add the resource, we can set up property of resource. I have a very few basic fields. First of all, item type is a flag that define basically how this resource can be used. It's blueberry can be consumable, craft resource. I don't think it's going to be a weapon. Also kind of trade commodity. Name, blueberry. Code name is essentially a string name, unique string to pick up from dictionaries and stuff later. I also call it blueberry. And as you can see, we have like two types of fields here, the two representations, the body, which is essentially visual representation of item, and the world as a 3D representation. For that, I'm gonna just use the blueberry GLB file exported from Blender. So you can see, I'm gonna even preview it here. And I also have icon. In later episode, when we're gonna work on inventory, this icon will be used to represent the same item in 2D kind of surface. And for that, I also rendered this item right in Blender into 2D pictures, and I can essentially add this 2D representation. It's ugly, not cropped, but doesn't matter. It's just like for demonstration right now. So once we set up the item All this information is already saved as a resource on the disk, so that's a good part. So this is a part of the data configuration. Now we can go to spawner and actually create another element. We set up a new config and we choose the resource. The cool thing is that because how it's set up, we already have all available resources right here. So we have stone, twig, blueberry. So later adding more resources, it's gonna be simple to just look up it here and add this resource. I have like 250 blueberries generated. Once we set up spawner, now we can run the game and we can see, okay, we have twig and stone, and also we now have a lot of berries around. Okay, now let's talk about how PickableItem is done. PickableItem is made as a generic scene with a area 3D to make it detectable by a player. It also has static body and it has a pick indicator that's shown when we want to interact. And we have a display placeholder node that will hold the mesh itself once the spawner actually generates this PickableItem theme. If you remember from previous episode, we had this spawn resource and we used to spawn a instance mesh itself. So now it's just replaced by the PickableItem, which created from this item factory create pickable based on config.resource. Config resource is essentially the resource base item. We also generate some random name for further lookup, and we obviously set the position where we want to spawn this item. If you go to this PickableItem, this is a static function because it's a factory method. It's basically generate PickableItem node based on this base resource item. We instantiate the PickableItem scene first. We set source as our base item, and we also put this into placeholder. Instantiate the body of this 3D mesh representation and put it into placeholder of PickableItem scene. PickableItem itself has a couple of methods to actually control the area and show and hide this little indicator when we ready to pick up something. Let's take a look again. So if item in the radius, it will show this indicator of interaction. It's not necessarily the best solution in terms of game design right now, but it's good one. We keep it for now. Now let's talk about the player and player composition and interaction itself. I spent several days to come up with a simple but scalable and easy to use architecture for that. This is where perhaps Godot content is lacking at the moment. The only principles everybody talk is signals up, calls down. Well, this is probably not the bad one to follow, but it doesn't technically solve a lot of architecture design problems. But hopefully Godot has all tools we need to make it work out. I found a lot of talks about global event bus, but unfortunately very few mentioned about why we can use a local event bus. And after some thoughts, I decided that this case actually where local event bus should be a great application. I called it Conductor. The main goal of Conductor is to basically relay signals and be a central hub for connecting all other components. In that case, each individual component can be wired to Conductor for both sending commands and receiving events. As you can see, Conductor is just literally 80 lines of code. It's pretty simple construction, even though it's so much powerful. It has a command which not necessarily needed part. You could directly call signals on Conductor, but it one step further to decoupling Conductor from consumer. So the command is like essentially interface between the entity and conductor to do something. I also have like simple, basically factory method to create it faster, just syntax sugar. I have a simple signal, and I have also a signal map. It's essentially the registry of all signals Conductor provides for command to be invoked. Register is adding a new command to the map, so other consumers can call it later. And invoke is essentially the call command and map this command to the signal to make sure that all subscribers to that signal receive it. With just a couple of validation stuff. Yeah, that's it. That's pretty much it. That allows like a lot of flexibility and kind of quite decoupling. If we take a look at specific player conductor implementation, it's even simpler for now because it's just like wiring like just few features together. So as you can see, there is no strict limitation who's gonna send and call which command. And okay, so the pick one is essentially command to pick item, and item picked is a kind of a signal that like something has been picked. And if we open the player scene, we can see how it's configured. So we have a player conductor and we have 3 features. So the player conductor will wire itself to all of these 3 features. And the cool part of that is like all communications, all this wiring is like one place. If you open the signals, we can see, okay, the pick one command is actually received by picker, because this is a feature that actually listens to the command and does picking. But when we pick item, we can see that the player itself receiving this command and do something like now it's just like printing text. And sound manager also receiving this part. And for example, sound manager, when it's receiving an item picked, it's actually playing the sound, and it also like have the item itself. So we can later plug here different sounds for different type of items. So how to call the conductor command itself? Well, let's check it out. The player, for example, handle interaction. I have this input manager which is interacted, essentially binding to a specific keyboard events or controller events. And once we have this event, what we do is we say, hey, conductor, just invoke this command pick one, and that's it. That's like the conductor does the rest. It's a route and like deliver this signal to any features needed. It can be picker, it can be anything else. And let's talk a little bit about picker. Picker for now has a command to pick first available item within the radius. The cool stuff is like picker can be configured. The radius itself is configuration. So in case if we need to implement features like effects that would increase the peak radius, or some magnet features that like collect like a bunch of item at once, like from the larger radius. That can be done like within the same feature picker, and we don't need to, spread this like around other code like in player or somewhere else. So the picker itself is essentially the area with a script that control this area, and it just has like those signals body, exit body, enter. And it also keeps tracking of all pickable item within the area, so it knows which items captured and which not. And for now we have only one method, pick one. It's essentially get the first pickable item from the list of available and basically pick it and send that, hey, yeah, item has picked to conductor pack. Yeah, let's check out the demo again. So we have a bunch of generated resources. We have stone, twigs, and berries now. If we come closer, we can see, hey, 2 items right now available into radius, and by pressing E, we actually picking up the first one from the list. Well, it's a random one. Pressing again, we pick second. So pressing 2, we're picking those. And you can hear the picking sound because the signal of picking item also wired to Sound Manager. So yeah, that's pretty much it for this episode. So in next episode, we're talking about inventory itself with slots and logic to place item in those slots. So that's it for today. See you all soon.